let me erase everything. In other words, you don't have to do this, your book does it this way, it's just justifying why it happened. As I said, if you just find out how you multiply each of these equations and use them as the exponent, you'll get the answer. And this brings us back to what we did when we were doing Hess's law last semester. So here, for instance, we have, like I said, we look for unique ones. There's N2H4, that always looks unique. I don't see any N2H4 here. There's an N2H4. Oops, there's another one, that's not unique. Let's forget N2H4. Okay, what else is unique? Nitrogen. Here's nitrogen. No nitrogen. This is the only one with nitrogen. Unfortunately, it's on the wrong side, so I have to use a minus sign to bring it over to the correct side. And this coefficient is 4. This one's what? 2. So if I multiply by minus 1/2, I'll get the right coefficient for the nitrogen. What's next? Well, the only thing I haven't tried is hydrogen. Unfortunately, there's hydrogen, that's not going to work. But I can look at this and say, well, I just have ammonia here. There's no ammonia in my final equation. There is ammonia in this equation. None here, none here. And so I have to get rid of this ammonia using this one. If I just wrote this out, and I'll write this over to the side, and I'll put my equal sign, minus 1/2 NH3 times 2 NH3 gives you minus NH3. This one has 2 NH3s, but it's on the opposite side. So what happens if I multiply this one by let's try that. It gives me 1 NH3, and the minus sign brings it over here. And it doesn't cancel out the first one, so I have to multiply it by what? Or does it? Yeah, it does. I'm sorry. It gives me minus 1/2 here. And notice this is a trial and error thing, but combining them and rewriting the equations is also a trial and error. So I multiply this by minus 1/2. It gives me minus 1 NH3. I bring it to the other side, and I have plus NH3. The NH3s are gone. Okay? And you didn't give me enough space to write here. So now this says I have minus 1/2 of these on this side. And I have some N2H here. I need to have how many up here? Did I miss anything? No, I didn't miss anything. I need 2 up here. If I multiply this by 2, I'm going to have minus 1/2 and 2. But that's going to give me, when I put them on the same side, 2.5. So what am I going to do with this? Somebody said multiply by plus 3/2. If I multiply this whole thing by plus 3/2 for my N2H4, I'm going to get 3/2 from this equation. This one already has a minus 1/2. If I bring it over to the other side, it has what? Plus 1/2 N2H4. Adding together, I get 2 N2H4s. So I've got a coefficient, I've got a multiplier for this one, a multiplier for this one, multiplier for this one. I just have to figure out what to do with the other one. And for this one, I'm going to use hydrogen. Okay? Because no hydrogen here, no hydrogen here. Here's hydrogen, and I already said it's 3/2 times 2. 3/2 times 3, which makes it 9/2. This one has hydrogen, so I have to multiply by minus 9/2. That gets rid of my hydrogen. Plus 9/2, minus 9/2. Okay, no wrong, there you go. So I've got multipliers for all of them. So now I would say K for that equation is 7.44. to the minus 1/2 power. Notice you can put it in the denominator and say plus 1/2, but you just leave it like that because you can have negative exponents times 8.2 times 3/2 times so you just multiply all those out, and that'll give you the K for your other one. So basically, these are Hess's law problems where you're using the multipliers for the equations as exponents rather than multiplicative factors. I had to slow down when I said it so I could get all the symbols and syllables in there. Okay. So these are variations of the Hess law problem. Now I think I did assign that one that said